Okay, hello everyone. Welcome to the 10th and last session of the Sunoikisis's Digital Classics Spring 2000 session. 10th and last session of the Sunoikisis's Digital Classics Spring 2000 session. Now you got it doubled. Sorry. Sunoikisis's Digital Classics Spring 2000. What is happening? Now you got it doubled. Sorry. My apologies, really. Let's start again. So this is the 10th and last session of the Spring 2019 Sunoikisis's Digital Classics program. And today we have the continuation from 2 weeks ago, which is the title of the class is Text Analysis, Stylometry and Visualization using R. And we have 3 presenters today, Maciej Eder from Kraków and Robert Gorman from University of Nebraska, Lincoln, and Christopher Ohge from University of London. And the notebooks, 2 notebooks and files that will be dealt with in this session are available in the Sunoikisis's Digital Classics class outline in the GitHub page, if you are looking for them when they are being presented. So now I will just hand over the microphone shortly to Christopher, who will start. So go ahead, please, Christopher.
All right. Thanks very much. During our last session a couple of weeks ago, we went over the basics of programming languages and regular expressions, and I attempted to show you some of the basic functions that can be accomplished in R. And I ended by showing you some aspects of R programming through the tidy text method. Now, before handing it off to Maciej, I wanted to just briefly go over what we mean by tidy text and why I use it in my practice and why it's a very useful way of programming. I should say that the notebook file that I created last session is on our GitHub page, and it's been revised, and I've added more to it, and I've made some corrections. Surely there are going to be other corrections to be made, but for now this is a slightly better version of the last notebook file. But if you go back to part 1 of the notebook file that I showed last time, where I indicated that we would use tidy text to read all of Livy's histories, once you get past loading these libraries that are pretty useful for tidy text mining, I just wanted to briefly go over why we use the tidy approach for a lot of text analysis projects. And this comes from Hadley Wickham's idea of tidy data, and he's been one of the leading figures in this discussion. But the basic idea is that tidy text mining reorganizes textual data into 3 different aspects. So each variable is a column, each observation is a row, each type of observational unit is a table, and what you produce is a data frame in which there's a table with 1 token per row. And I just wanted to illustrate that by showing you in the notebook file what I mean by this. So in the last session, you saw that we could create a text vector by using the C function. And the C function can just include strings of characters. So in this case, I've taken one of Ezra Pound's famous poems, which is only 2 lines, which is very good for our purposes. And I've created a text vector, or a character vector, that is, using the 2 lines. And if you run this, you'll see that here's our character vector. But from a tidy text standpoint, this still needs some more processing. So the vector that we currently have is just 2 strings of text, and we want to transform this into what I'm calling the tidy format, or what we call the tidy format. And that means simply turning it into a data frame And in R, they're called tibbles, which is a certain kind of tidy data frame, which is really convenient for text analysis. So we create a new vector which converts what we just did into a data frame. And if you run the program, you'll see that now we've got a line number and a text character string output of the 2 lines. And this is slightly better than what we did before, but the essence of tidy text mining is using the unnest tokens function. And essentially what we're doing here is taking each word in each line and breaking it down into a meaningful unit, which for us is a word. And here's the unnest tokens function. Here is the output, which is the word, and the input, which is the text, which is our 2-line character vector, and we're breaking it into words. Pretty simple. And what you can see from the output is we've now transformed this into a data frame where there's a line number, and each line number pairs up with the word associated with its line number. And you can see that not only has each line in the poem been broken down into words, but the original line numbers in the poem are retained in the output, which is very handy for text analysis. And this is essentially the foundation of tidy text mining. And if you go through the rest of the notebook on our GitHub page, you'll see that everything that follows using the Gutenberger package and creating various text analyses and sentiment analyses and creating word clouds, all of that comes down to the essential work that you do with reorganizing textual data into tibbles or data frames with the tidy text package. I don't want to dwell on that too much. We'll leave some of the nitty-gritty of this work for our in-person seminars coming up. And in the interest of time, I'd like to now hand it over to, let's see, hand it over to Maciej. He will talk to us about stylo.
Yeah. Hello, everyone. And yes, my name is Maciej Eder. I'm from Kraków. I'm from the Polish Academy of Sciences, Institute of Polish Language. And I will be talking about stylometry and the package stylo, which is designed to do some stylometric analysis. Stylometric in terms of computational stylistics, or more precisely, authorship attribution. And I will start with a very short introduction, theoretical introduction. I'll just switch to some slides. Yeah, a very short introduction on some major assumptions or basic fundamental assumptions behind stylometry or authorship attribution. Authorship attribution might be of interest of the listeners to this seminar, because in the classical studies, there's quite a number of texts that might, I hope, will be attributed one day. This is, some text of Plato, some text of Aeschylus, Euripides, Demosthenes, Appendix Virgiliana, you name it. There's a bunch of them. So before we go any further, I should introduce you to the general idea of, what is being measured, what kind of linguistic features are or should be measured. And this brings us to the idea of stylistic or the stylistic fingerprint, which is a theoretical assumption that every single person has his or her own linguistic features, language features that are unique to them, that are not to be imitated in a simple way. And the idea is that we, when we listen to a poem, we can guess that some expressions, some phrasal verbs are quite typical to a person, but this is nowhere where the authorship attribution tries to find its style markers or those linguistic features. It is mostly about the features which are not to be discovered with the naked eye. This is the features that are very hard to control. This is the features that you use or we use subconsciously or almost subconsciously, that are resistant to parody, plagiarism, etc., etc. And a very popular solution is to focus on the function words or grammatical words. And I will say a few words about this assumption in a minute, but the question is and has always been if it is possible to have 1% probability of getting or guessing the author. And one of the first pioneers of stylometry said yes. If you can send someone behind bars because of his or her imitation of handwriting, then even more with style, which we don't believe is the case anymore. So what we seek, what we are looking for is some features that at a certain statistical level will or might show us the probability of the authorship of a given work in question. So I've mentioned grammatical words or function words. And these are the words that, this is a linguistic glue, the words we don't pay any attention at when we speak, when we write. But as you can see in this very simple example in English, they are responsible for roughly 1/2 of a language. So all those words marked in red are the function words. And as you can see, it's roughly 50%. In the more inflected language, like ancient Greek, like Polish, like Latin, there's still a considerable number of those words, like 1/3. So there is a theoretical assumption that those function words are very good markers for the uniqueness of style, authorial style. Now, having said that, or having defined this idea of fingerprint, the question is how can we extract such a fingerprint from a bunch of texts or from an anonymous text? And the next question is how do we measure those similarities and dissimilarities? There's one super important thing to be said right now. The computer is not a machine that simply gives you an answer just like this. Stylometry is always about comparing. So if you've got a text, if you've got an anonymous text, the only thing you can do is that you can collect a number of texts written by possibly the author of the text in question, and to compare different candidates for authorship. So the question is, which out of the text collected in the reference corpus turned out to be the most similar to the text in question, which brings us to the idea of nearest neighborship. So mathematically speaking, or geometrically speaking, what we are seeking is the nearest neighbor. So the text that is nearest in terms of its similarities, statistical similarities to one of the candidate authors. Okay, so switching from theory to some practical applications, we might ask, so how does this work? How does it like? And it is as simple as that. We have to collect the frequencies, the word frequencies. So we have to do the things already introduced 2 sessions ago by Christopher. We have to count the frequencies of words in the entire corpus rather than in one single text. And this is an example how this might look like. So for every single word, for every single style marker, the, to, and, of, I, a, these function words are serving as style markers here. So for every single word in question, we want to measure their frequencies in particular text we're interested in, right? And now, having this table of frequencies, we do some math. I'm skipping the details unless someone is interested in listening, in learning more about the details. I'm skipping the maths right now. But the general idea is that you can convert those frequencies, those relative frequencies to be specific here, into another table, into a table of differences between texts, differences or distances, as we usually call it, using some mathematical background to define those differences. So these are differences or distances between texts. And now the nearest distance means the nearest stylistic similarity. And that's basically it when it comes to stylometry. But stylometry is ambitious enough to take the next step, which is it tries to visualize the results. So having this table of distances between texts, we might try to visualize them, and there is a number of methods to do so. But one of the very simple a very simple example of such a method, and a very simple to interpret, is hierarchical clustering and a resulting dendrogram. So here in this picture, you can see a dendrogram, which is a tree-like structure in which you can identify some branches, sub-branches, and leaves being the texts. And now you can see that Milton has been recognized to have written 3 different texts. The computer had no additional information about the labels of those texts. The labels are attached afterwards. So the computer itself, or the procedure itself, recognized some stylistic similarities. So Wordsworth has been recognized as being similar to himself, same about Tennyson, same about Patmore, Browning, and so on and so on. And this idea is used to do the real case attributions as well, because having an anonymous text among the texts of known authorship, the goal is to identify on which branch the anonymous text ends up, and that's basically it. That's a different approach to the same problem. This time there is a 2-dimensional scatter plot in which you try to identify the clouds or the clusters of text which are stylistically similar. Here we've got 3 distinct clusters, and this is because we deal here with 3 distinct authors: Dickens, Conrad, and Jane Austen. And you can see there is you can simply tell them apart just by manual inspection of this picture. And that's another approach to the same problem, but in the same case, this is a real case application. Some of you might remember that a couple of years ago, a book appeared penned by Mr. Galbraith, Robert Galbraith, entitled The Cuckoo's Calling. And no one knew who the author of this book was, because this Mr. Galbraith presumably didn't exist. And there's a study in which a study done by our colleague from the Duquesne University, Patrick Uola, who showed, who has proven that this Mr. Galbraith is in fact J.K. Rowling. So yes, we can do it with stylometry, and we can do it with R, and we can do it with some packages provided by R. But also, having said that, stylometry is much more than just authorship attribution, because a written text is much more than just authorial signal or authorial uniqueness. There is much more layers that you can try to extract from text using stylometric approaches, such as chronology, such as translatorial signal, such as education or gender. You can tell apart books written by men and women. You can go even further and try to identify some genres. These are the possible applications of stylometric methods, such as that one. This is a very simple toy example in which I've taken 28 Polish novels covering 100 years. And as you can see, there is a nice transition from the early 20s to the late 20s books in here. The transition goes diagonally here. Another example is translation. A colleague of mine, Jan Rybicki, also from Kraków, from the Jagiellonian University, wanted to find out who was the translator. He knew that there were 2 translators of Virginia Woolf's Night and Day. He knew who wrote the first chapter, he knew who translated the last chapter, but he didn't know where the transition point was. So he has taken the first and last chapter, and that's the result of his analysis, showing that the breaking point is the chapter 28, which turned out to be true. So the translatorial signal is also there. That's another example of stylometry beyond authorship attribution. A colleague from Amsterdam, Professor Karina van Dalen-Oskam, told apart or actually separated different words spoken by different characters in a novel to see if there is any distinction between different characters. And she was able to identify some groups of characters in those Dutch novels. And last but not least, something coming back to the classics. And there's a very simple, maybe not very informative example of 124 Greek texts that I've taken from different sources, mostly from the Perseus project. And as you can see, there's a Bootstrap consensus network analysis outcome in which you can see those books clustered by genre. So this two-leg octopus has its head, which is epic poetry, Homer, Hesiod, Apollonius, Nonnus, drama, Aeschylus, Euripides, Sophocles, Aristophanes, and prose, Isocrates, Aeschines, Elianus, and so on, the New Testament. But also there's a chronological transition from the oldest books to the newest. But also, and in the first place, there is a authorial recognition because all the samples by Homer are being kept together. Same about Isocrates, same about Euripides, same about Aristophanes, and so on and so on. So there is quite a number of possible applications of stylometric methods. And having said that, we can go back and try to fire up R and to do some analysis with R. So in this notebook, there's some instructions how to download the texts and how to just start sharing the screen. There's some instructions how to download the data set and how the data or the texts should be formatted. And it is as simple as that. I've just downloaded the texts, which is the New Testament in Latin from a GitHub repository. A link is in your notebook. Now, having done that, I've got it here on my desktop. I've just unpacked it. There it is. This is the Acts, Apocalypse or the Revelation, the Epistle to Corinthians, and so on and so on and so on, and of course the Gospels. So to do a very simple stylometric analysis with R, first thing I have to do is to create a new directory or folder. I can name it, say, NT_Ohge. You can name it as you wish. Oh, it's already taken. So New Testament. Now within this folder, I create another one which should be named Corpus. It doesn't have to, but it's really convenient to do so because there's a default name for the package stylo. And now this folder, this subfolder Corpus, should contain the texts I'm interested in. So I'm just copying the New Testament in here. So consequently, I've got a folder that contains a subfolder Corpus that contains the texts in question. This is it. There is no anonymous text actually in there, or most of them are anonymous, or we don't know who the author of them was. That's a complicated story. We'll be there in a couple of minutes. Now, time to start R. I will not be using RStudio this time, but you're encouraged to do so if you want to. I will use a regular R console instead. As I said, you are free to go if you want to launch a very, very simple Linux or Windows console, such as this one. By firing up just R, you're also encouraged to do so if you're interested. I will stick to the very simple R console for the time being. So now the thing I have to do is to load the library stylo. It takes a minute. Yeah, it's there. Now we are almost ready to go. Now, one session ago or two sessions ago, there was quite a lot about text mining with R, but also what is quite important, it has been already mentioned. This is the navigation on your hard drive, because if you want to tell R that your corpus is over here, you need to tell R somehow how to find the files. And to do so, there is a number of commands or functions. The most important one is set working directory, set WD. This is the function that tells R where to go. In my case, I know that I'm on desktop, right? So I can go directly to desktop. And then I know that I'm in the New Testament subdirectory. New Testament, right? I can click OK. And to see if I'm indeed there, I can use get working directory to check, yes, that's fine. I can also see if my corpus subdirectory is there by list files. It's there. So far, so good. We are all set, it seems. So there are three things to be done. We've done two already. The first is to set working directory. The second is to load the library stylo. We've done it at the beginning. The sequence of those two steps doesn't really matter. And the third is to fire up or to launch the function stylo from the package stylo. But before I go there, just one hint. Using the RStudio, you can set the working directory just clicking on the right panel the desired subdirectory. Using this very simple R shell in Macintosh, you go to miscellaneous, and you also have got change working directory options. So you can do it by clicking a button. And on Windows, there is a very similar thing on R shell for Windows. You click File and then Change Directory. And this is it. Now, having done those two steps, we are ready to go for the third step, which is just type stylo, empty brackets. Within the brackets, you can provide one of 120 additional parameters, but we will go without any parameters for the first and for the second time. That's enough. Just to type stylo and followed by empty brackets. And now, I haven't said that, but the package stylo is designed to do stylometric analysis also for novice users of computers, for those who have no experience in programming. And this is because it is supplemented with graphical user interface that you can switch off, but in the default mode, it is switched on. So that's the graphical user interface, which has 5 different tabs with many options provided. But for the first time, what I would suggest is just to click OK. Just to click OK to see what happens. And that's the result. The texts from the corpus have been loaded, have been tokenized, and a dendrogram has been built out of those frequencies. And this is the final result. And on this dendrogram shows us a few branches, a few, and the leaves, of course, which are the text. And as you can see, in the lower part of it, of the picture, we've got the epistles, Romans and Corinthians and Jacob's epistle. We've got a distinct John's Gospel. We've got some Luke with a little bit of Maciej in there. The question is why the ending of the Maciej Gospel and the ending of the Luke Gospel are linked together. And the reason is that, yes, because they share quite a lot of material, and because this is about the passion of Christ. So everything is as it should. And we've got the Acts somehow linked, but not really to the Revelation. And now the attribution question that might follow is, so was the author of the revelation, so Saint John, the same Saint John who wrote John's Gospel? And no, it was not the same person. That's what the biblical studies already know. So we've done our first analysis, and as you can see, there is a very simple dendrogram using basic settings, which is 100 most frequent words have been used in this case. Now, what if you want to use 200 words instead? You go for the function stylo again. And again, this graphical user interface will show up, and you can switch the features. Features, this is the second tab, on which you can say you're interested in 200 words rather than 100 words to see if the results will be similar or not. I'm clicking OK, and that's something else. It's not identical. Especially the synoptic gospels are looking differently, right? So the good question to be asked is, which out of those two dendrograms tells the truth? That's a big topic in stylometry, reliability of stylometry, and there is different approaches to crack this problem. The approach which is embedded in the package stylo is to use Bootstrap consensus tree. So this is a method that goes and produces virtual dendrograms for different settings, and then sums them up into one consensus tree. Let me show you how it works. What I can do, I can say that I'm interested in, say, 100 features, 200 features, 300 features, all the way to 1,000. That's the minimum 100, the maximum is 1,000, and the increment is 100. And on the tab statistics, I switch from cluster analysis to consensus tree, which is this dendrograms of dendrograms, which is this consensus tree. That's it. And this is a combination of 10 different dendrograms for different parameters, which is supposedly much more reliable in comparison to the previous one. Now, we could go through all the parameters on this graphical user interface. There's quite a lot of them. Let me just dedicate one short minute to some of them. In the first tab, you've got the language settings. If you do some analysis with ancient Greek, you probably would click the other language, which switches on all the non-Latin characters such as Cyrillic, Greek, and so on and so on and so on. On tab features, there is the number of most frequent words that you want to analyze. Very important setting. There's quite a lot of other important settings, but I'm skipping there now. On the tab statistics, you can choose between a cluster analysis, multidimensional scaling, two different variants of principal component analysis, consensus trees, and for some of those methods, namely for cluster analysis, consensus trees, and multidimensional scaling, you can choose one of the distance measures. So this is the mathematical kernel. There's at least 10 of them available to be used with the package stylo, with the function stylo. But there is much more that you can link to the package, and it is up to you which out of them you will pick. In this notebook, you've got a link to some short discussion on how a perfect distance measure should be chosen. This is a very, very big topic that I'm skipping right now, just pointing you to this resource. The next tab is about sampling, so you can cut your text into samples or randomly sample from those texts. That's quite self-evident, so I'm skipping that for now. And the last tab is about output, so you can produce PDF files, PNG files. You can reshape the final pictures, and so on, and so on, and so on. Okay, having said that, because we are running out of time, let me just tell you about some different methods that are also embedded in package stylo. One of those is referred to as Bootstrap consensus networks. And there is a method that tries to leverage Bootstrap consensus trees into a form of a connection between nodes. Stylo networks. A very similar network, maybe singular. A very similar graphical user interface applies. I'm just clicking OK for the first time, and it does what it is expected to do. And now I hope you can see that this New Testament is represented in the form of a network, which is quite dynamic. You can pull the nodes, you can see what is connected with what. In your notebook, there is a very brief description of how to produce such a network. And having said that, because we are running out of time, I think it is a good moment to just briefly show you what else is in the notebook. We've covered some of the functionalities of the function stylo from the package stylo. We've seen the Bootstrap consensus trees. That's how it looks, and here above is how to produce it. But there are also some other methods. That Bootstrap consensus network, you've seen that already. You know how to produce it. But there are some other methods, and to name but a few, I think I should mention at the first place classify. This is a function embedded in stylo, which is dedicated to do, or which is aimed at doing supervised analysis. So real case machine learning analysis, in the case of which you train the model and then you apply it to some fresh data. This is a huge topic that I'm going to skip right now, but I need to mention that this function, having different methods, exists and it is embedded in stylo. Another one is the function of pose. The function of pose, which is aimed at comparing two subcorpora. So assume you've got a corpus of prose and a corpus of poetry, and you want to find out which are the differentiating words. So the oppose function is the one to be used in such a case. And last, but definitely not least, there is a rolling classify method, which assumes that a text is not an entity as it is, but you can slice it into consecutive samples and assess them sequentially one by one. In this example that I hope you can see, in this example, there is a Roman de la Rose, so the 13th century French allegoric poem, which has been written by two different authors, and we know the transition point, we know the takeover point. I've marked it with this dashed line. And now the model has been trained to detect different takeovers, and as you can see, as we go along the development of story, there is a big transition in here, but also some parts of the second authors in the first part, and some tiny part of the first author in the second part, which I don't really know how to explain. But using this case, using this method, you can assess longer text that you think might have been written by more people, or the text that you think might contain more than one stylometric signal. And having said that, I think there is a good moment to hand the mic to Gabriel to take over. So thank you very much, and I'm waiting for some questions in the discussion part.
Okay, I guess, can you hear me?
Yes.
Yeah, okay. I'm Bob Gorman from the University of Nebraska, and I am, let's see, let me make my, my screen share thing work. There we go. I'm using the kind of R version of Notebook because I have a little trouble getting the HTML one to function sometimes. Now, what I'm going to talk to you about is matters that you're pretty familiar with, I suppose. It's about doing things like classification, doing data analysis.
Oh, could you make the text a little bit bigger, please?
What's that?
Could you make the text a little bit bigger, please?
Yeah, I suppose I can. Well, if you.
Thank you very much.
How about that?
Great, thanks.
Yeah. Like I say, and if you're using the HTML version, it should be easier to read when the students look at it. But my interest here is bringing into play syntactic information. So not just word, lexical words, vocabulary words, and that's what you usually find in such analyses. But one can do a lot of interesting things with syntactic information, and we have these tree banks that you've been discussing this semester. And so what I'm going to talk to you about is how to extract some kind of stylistic information, stylometric information from tree banks. And what I'm interested in here is just a brief example about word order, about analyzing features of word order using tree banks and R. So I have some of the packages here you can see that I use. One of the most important one to note is XML2, because I'm using the Perseus tree banks. We work on those quite a bit, and generally they're available in XML format. So you need a way to get the XML code, well, to get the data from XML code and into a form that R can manipulate it. And this program works pretty well. I also use the plain XML package, which is also very, very helpful. All right. So I've already loaded my data. I've provided some files to the students in this Sunoikisis. You can get them on the site. But I'll just show that I've picked some random files here to work with. And oops, that wasn't what I meant to do. Here we go. You see that they are Aeschylus, Agamemnon, etc. And I'm going to pull out some the data from these files and then calculate the entropy. We can talk about entropy later of word order. Now here is the code necessary to read the XML into an R object. And here I've decided, you see this index number 3, I've decided for demonstration purposes to use Herodotus. Now I've set a loop so that you can get all the sentences later on. And if you're doing this at home, as it were, you should also write a loop so you can just, so it'll automatically go through the files in the directory. But here I'm doing it by hand just to quickly show you what the important steps are. Now here, word order can't really be calculated in any kind of reasonable way without syntactic structure, because we're not interested in just say where in the sentence a particular word occurs, but where in a sentence a particular syntactic structure occurs. So does a subject come before a direct object or before an adverbial construction? And all of this kind of data, of course, is in the tree bank, but it all has to be calculated sentence by sentence. So in this broken down version, an important step is to extract your information by sentence. And to do this, I use the XML find all function, and I give it my input object. And then here is the syntax from XPath, which is used to find the elements that I'm interested in. And this, you have to be familiar, read up on XPath syntax. This means a sentence occurring anywhere in the XML structure. That's what the two slashes mean. So as a result of this, I end up with a XML object that you see has a different entry for each sentence in the XML document. You can see that. Now, my advice when working with XML in R is to get out of XML as quickly as possible. The XML packages allow you to manipulate XML documents, calculate, analyze them, leaving them in XML format. But I don't like to do that. I like to move out into R as quickly as possible, into R objects. So here I use XML find all, again, pipe to the XML attributes, because what I'm interested in is the attributes of each word. And I'll show you those in a minute. But what this does is turn an XML object into an R list. So hence I call my output object, my target object, word.l for list. So a good idea to give your R objects little mnemonic suffixes and so on. So if one follows bits along, one gets word list, and you can see it scroll by there in the form of a list, and here it is up the top. Each entry gives you the output. Oh, it looks like I've left it in Latin. I forgot to change the number. This is Cicero here, but that's okay. It's easier to read. The Greek doesn't always show up properly on the output here. Sometimes it just gives you the Unicode code points. So you can see that there is an ID for each word, a form, which is the way the word occurs, the token of the word. Then there's the lemma and various morphological information. And then the stuff we're really interested in, the syntactic relation. Here, this word is the subject, and an index number telling us what the parent is. And with the relation and the parent code, you can really do some interesting analyses and so forth. So those are the keys. So what we've done now is move into R, and now I'm going to, the next step, crucially, let me keep an eye on the time, the next step is to put it in a tibble, really. Lists are not that easy to work with. Tibbles, as you learn, are really nice to work with. So this little code, and I won't go through the details, deletes ellipses, because an ellipsis in the Perseus tree banks, you often have to put an ellipsis in to put the structure of the sentence together properly syntactically. But obviously, they should not be considered when you're testing for word order, because you've added it, and it doesn't exist in the original sentence. It's just a structural convenience. And so I happen to know that if a word has an ellipsis, it has more than 7 attributes. So I easily just use a which command, a which function that only that limits my output to only those tokens that have 7 attributes and so forth. So I'll just run through this quickly. You can read about it. I've written the code, and now we have I've annotated the code, I mean to say. So now we have a tibble for this particular sentence, which has again the bits and pieces that we want. And notice that we've had to double check to make sure, always double check to make sure the things that are numeric, that should be numeric, you want to be numeric, are numeric. Here this time, because I've run this through earlier, it turns out everything's okay. But I had to make sure, I had to change the head and the ID from text characters to numeric. So keep an eye on that kind of thing. All right, and we're going pretty fast here. Now I'm taking the input and computing dependency direction. Why am I doing that in a word order study? Well, it's because we, oops, sorry about that. It's because we have to avoid sparsity. If you have a 10-word sentence tree, a dependency tree, you have roughly a billion possible tree forms. If I'm remembering correctly, it's something like 10 to the 8th or something like that. If you have 20, it's 20 to the 18th power. So there's a huge number of possible structures underlying a tree bank. And in order to check word order, you want to hold the structure of the tree bank constant and say, for a given structure, what are the various orders that occur? Okay, and you also want to hold it constant for individual vocabularies. You say, okay, given a certain tree structure and given vocabulary that's the same in each instance that I'm examining, I'm going to look to see how the word order varies. Well, of course, you're talking about a huge number then. So sparsity would be immense. Sparsity would be immense. You couldn't do it. Even with a trillion-word corpus of English, the sparsity is too much if you're looking at all the words and all the possible syntactic configurations. So what we do here is simplify and simplify and simplify. So all we're going to compute is basically statistics and measurements for whether a word is before its head in dependency syntax or whether the word is after the head. And this, if you read the bibliography I put online, this can give some very interesting results, and it's pretty much resistant and robust against sparsity. So that's what we're doing with dependency direction. So I'm using some of the things you probably learned, mutating when I put in, I'm putting in a new column. So here's my my tibble, and I've added an arc direction column, and then we go through and run the code. I'm going to check again at the sentence tibble. It's now put in arc direction. The parent precedes, the parent follows, and so forth. Now, one of the things you might want to do, and you definitely, I recommend it if you're working with tree bank data, is expand the morphological code. I've added a part of speech column because this is the morphological code over under the post tag. And P stands for pronoun, but how do you know it doesn't stand for preposition, right? R stands for preposition. You can easily get confused. So there's no reason not to just add a category that makes things more legible for the human being. And so you see now I've snapped in the full spellings from the post tag bit. All right. Now there are other categories that we're interested in when we're doing this kind of analysis, and I won't go into detail. You can read about it. But we need to know what the part of speech of the parent of a word is. We want to know what the syntactic relation of the parent word is. And this is pretty easy to do once you have everything in the tibble form. And here now we have not only the part of speech of the word, but the part of speech of the parent of the word. And so suddenly now we can find out lots of interesting things. We can do, and I've done, for example, classification, and authorship classification works extremely well on some of these, with some of these categories, syntactically. So we've got, this far, we've got the basic information that we need in order to do entropy calculations, okay? And that's where we're going. Now I've added here a loop that will take all the sentences in this author, so I'll just run that through there. Takes a few seconds because it's kind of slow when you run it through the notebook. It's a lot quicker when you just run it in an R console. And our results here, 11,333 tokens in this file. And now I'm going to use some of the tidyverse commands, which are very useful, to make a tibble from which we can calculate entropy, okay, which is just a kind of standard measurement used by lots of people who study word order. And so what I've done very quickly, I can put together a code that tells me for a given part of speech here, is it more likely in Cicero that an adjective, for example, precedes or follows its parent? Or in fact, I put it the other way around. So usually it says that the parent follows an adjective. In other words, the adjective precedes, and so on. So you see how quickly we can put together some basic information. And now it's just a question of adding the mathematical calculations for entropy. So I just run a few columns to get added columns to put the data into. You see I've added the probabilities because entropy is figured on probability, which will be built on the count. Surprisal, which is essentially a logarithm of the probability, which tells us how odd it is that we should find something. Entropy is simply weighted surprisal, so it's just a calculation built on surprisal. And summed entropy is kind of the overall word order variation in a system. And so I have a little loop that will give us that. Oops, wrong one. There. And you can see, for example, that in Cicero, if we just look at the summed entropy, basically the lower it is, the more rigid a system of word order is. The higher the entropy is, the more free the word order is. That is, the less predictable it is. If I just tell you, here's an adjective, is it going to be before or after the word it modifies? In Latin, here you maybe could not predict it very well, but you could predict it better than you could predict whether a conjunction is going to come before and after, and so on. So I won't go through like this. I could say the calculations for entropy, they're very easily available, widely available, but I've run out some other bits here in case we want to be more drill down. We might want to drill down. Here I've said, okay, what if we only want to look at nouns and how they occur relative to their parents? And you can do that, or you can change the code to look at anything you're interested in with respect to word order. And this is very useful for students who don't know how to. Looks like I've done something. Oops, I forgot to hit a button. There we go. Here, for example, is the tibble that only looks at nouns, and we can see that sometimes that certain structures are much less predictable. Attributes, for example, in Cicero, that is, a noun modifying a noun, a genitive, is almost completely unpredictable. It has an entropy of almost 1, which is the maximum when you only have a two-element system. This is quite interesting. And if you compare, as you can do, the entropy of different noun functions from beginning with Aeschylus, moving through Herodotus, moving through Plutarch and Polybius, you find that word order, certain entropy decreases, for example, and certain word orders become more fixed in the language, and so that Polybius is more likely to use a more fixed word order than Herodotus was, and so on. So, all right, I know I've gone very fast, and I see it's just turned 12, so I can stop there. I mean, the code is there, it's annotated. I'm perfectly happy to answer questions by email if anybody is interested in learning more. Okay, thank you.
Thank you very much, all three of you. This is really fascinating. I can't wait to start testing with tree banks. And so, any comments and questions from anyone in the call?
Well, I've used Stylo before. It's a very nice program. I like to use it whenever I can. I'm not sure a person could use syntactic information in it. I had to write my own code. Although I have done that before, you simply extract the syntactic information and treat it as if it were, treat each syntactic relationship as if it were a word. And then you can feed it into the Stylo interface, and then it'll come out with some good results. So a person you don't have to work on the tree banks in the way I've done it. There are other ways of approaching them.
Yeah, we are here at a very, very important question, actually fundamental question of the style markers. Is it just the function word frequencies that make a style, or is it some more syntactic and grammatical information that is unique for different authors? And yet it is. The thing is that it is super simple to extract just frequencies of function words, and not so simple as we have just seen to extract the grammatical information about, say, word order, right? That involves some sophisticated machinery, and that's a problem that in many languages we've got no taggers, no other parsers. So one is very lucky when one has a tool to do so. But basically, whatever you have, you can use it as an input for a stylometric system, such as Stylo. You just need to have a table of frequencies of this thing you're interested in. You should go. You should work.
Yes, that's true. It does work for this kind of thing.
And to just focus for a sec on word level or lexical level features, if we've got a sentence or just running text in any language, let's focus on Latin. We can slice it into units. Doesn't need to be words in different ways. For example, you can slice it into just words, ni vestra auctoritates suffoltus patres and so on, or into word bigrams, or combinations of two adjacent words, ni vestra auctoritate suffoltus, and so on and so on. There are some engineers that claim that you can go even further and to slice your text into character engrams or character sequences. I don't like it. As a linguist myself, I don't like this, kind of thinking that trigrams, character trigrams, is any linguistic unit, but still it works. It's a very, very, very efficient way of extracting the author information. And now, if we could enrich it with some grammatical information, that would be fantastic.
Right, that's true. Yeah, I've done some good work with this. I should be publishing it soon. So, as you say, fortunately in Greek and Latin we have hand annotated tree banks. I don't know how well the parsers work on Greek and Latin. I haven't really paid much attention to their results, but certainly, yeah, I think we'll be seeing more and more syntactic analyses appearing day by day.
Yes, that's actually an interesting question there. When we have quite a lot of hand annotated data for Greek and Latin, but then I was curious then, do you often see when you do this analysis that there is differences not based on maybe the author, but maybe also the way it has been annotated, that there might be actually, you might find differences of different annotators and not the actual author?
Yeah, you certainly will find inter-annotator disagreement. Now, I am fortunate because I have I've got roughly 500,000 tokens of prose in Greek done by the same person, so that makes it easier. But if you pick the level of analysis correctly, here, it's very unlikely that people are going to differ on whether they say a word is a subject or not, or a word is an object or not. You know, some of the more the finer distinctions, different uses of verbs, for example, whether it's going to be participles can be analyzed as adverbial or in other ways as well. That can get tricky. But when you're talking about subjects, direct objects, adverbials, I think that you'll have a very high level of agreement, especially when you're just talking about nouns. I mean, that's about as simple as you can get. So that's my guess.
If you wanted to compare the results in stylo between just focusing on function words or privileging function words and comparing that to privileging hapax legomena or type token ratios, is there a way to switch that on and off in stylo?
Well, yes and no. When it comes to hapax legomena or some rare vocabulary, you can just switch. You can just switch off the function words, and you're all set. But it's quite tricky to use some vocabulary richness indexes or other indexes like entropy or whatever you want directly from the text themselves. Rather, you're expecting to prepare your measurements outside stylo and then to feed stylo with this table of whatever you think might be calculated. But the question is, you know, the hapax legomena for us, for humans, this is a very promising style marker, isn't it? Whereas for a computer, this is too rare, too sparse to extract any information from that. So it does not really work, it turns out.
Yeah.
And back to the question about different annotators, this is a question of I would say, noise in the data, right? And some systematic errors in the data. If the systematic errors is indeed very systematic, so even if it's slightly wrong, but done by the same person who is biased in one direction for the entire corpus, you're fine, right? But if some samples are annotated with different people with different biases, then some fake signal might appear. That's the thing with punctuation, which is a very, very strong discriminator, especially in authorship. But when you switch to ancient Greek and Latin and include punctuation, then you might be very, very wrong because of measuring the impact of the editors or scholars rather than the authors, right? So you need to be aware about these potential sources of noise.
Yeah, it's good to keep in mind quite many things that can suddenly intervene with your results. I was also one question for Bob. I guess you were measuring about the distance, what precedes and what follows. But have you been doing sort of also adding the distance there? So it's for how far something follows or how near something precedes.
Yeah, I have a whole kind of line of research on dependency distance, as they call it. So there's a lot of work in linguistic and computer fields about dependency distance as a linguistic feature, because there's supposed to be a human principle of dependency distance minimization. So measuring how far a word is from its parent is, of course, important. Now, yeah, and then there's also, which is a little trickier, to measure whether the dependencies cross. That is, whether you've got something called projectivity, in which all parts of a subtree are contiguous in linear time or linear space, and non-projective subtrees in which they are not contiguous. And so there's lots of different permutations and different things one can measure. But yeah, I definitely like to measure how far something is from its parent. And like I say, there's good research on this. People are discussing this as a feature of language development and so forth.
Yes, thanks. Any more questions or additions of what you have been saying?
I'm glad to have been here. It was fun.
Yes,
Definitely.
Yeah.
And like I say, if anybody has questions, it's sometimes code breaks. Our code can break pretty easily when you run a new XML file through it. Because sometimes if somebody leaves an annotation out, you try to foresee that and write your code to handle that, but unexpected things occur, and then the code will break, and it might be that students get confused. So feel free to contact me.
So, anyone else have any questions? I'm just checking quickly the chat in Google, and there is no questions there. I would really like to thank all three of you for these sessions with R. They have been really educational, and I'm sure there will be lots to work with when trying out these and following the notebooks. And this being said, thank you all for following the whole Sunoikisis Spring session. Thank you, Gabby, very much for organizing this. I think you have been doing more work than I have with this. So thank you all very much, and enjoy the rest of the spring.
Yeah, thanks.
Thank you.
Thank you very much.
Really cool. And for anyone who hasn't had yet enough of Sunoikisis's digital classics, it'll be back. Well, wait for the emergency vehicles to pass. It'll be back in about 4 or 5 weeks with Monica Bertie's summer semester of Sunoikisis's digital classics, where you will see 1 or 2 familiar faces speaking some point during the semester then as well.
Okay, so thank you very much, and bye-bye.